My name's Isaac Christoffersen. I have Brian Koga here with me as well. I'm from Missouri, Brian's from Ansible. Today we're going to talk about sort of using Ansible to try and integrate both traditional environments as well as new, sort of greenfield environments as well, and trying to use the same sort of tool set. Talk a little bit about some of the upstream, the new stuff coming out. You hear a lot about OpenShift v3 this week, if you haven't already. And I'll have a little bit, if my display driver holds up, we'll have a little bit demo here of Ansible Tower with legacy environment as well as talking to OpenShift v3. So some of these slides here, so we're really talking about my role. I'm a consultant working with a lot of different companies to try and help people deliver their applications and their environments faster, right? But it's getting harder now because, any day someone can just go up there and put in a credit card and spin up a new environment and then it should be ready to go, right? But it gets harder and harder when for the new stuff. That was great for Amazon, but if you're sitting there and running into a traditional virtualization environment, it gets harder. It also begins, for enterprise environments, it starts to get harder because you have all this legacy information, databases, mainframe systems, whatever, that you still gotta integrate into this new web technologies. In addition, we're really talking about changes in the way we do IT. So we have a change in development processes, right? So we're no longer, some of us are still have waterfall projects, but we're moving faster, right, to more agile. We're moving faster to more DevOps. We're breaking up our applications. We no longer have just big monolithic applications. We actually have little small pieces of those, and they go all over the place. A way we deploy things, right? We no longer talk about deploying things in physical servers. We talk about deploying things in virtual machines, even now, containers, right? I guarantee you're going to hear a lot about containers this week as well. And we're no longer hosting them within our firewalls. We're now hosting them out or in somebody else's firewalls. We're now in sort of cloud environments. And so all of these things, it's not just as we've moved down this chart that we've gotten rid of the stuff at the top, right? We still have waterfall processes we have to deal with. We still have monolithic applications we have to integrate into our environment. And we still have to deal with the stuff in our data center. And there's a lot of valuable assets in those that we need to be able to keep. So one of the tools that we've been looking at using, and we've used a lot to help come up with a simple common tool set that we can use for both these legacy environments and the new one, is Ansible is one of those tools. So I have Brian here. He's going to talk a little bit about Ansible as it comes up.
Hi. I work for Ansible. I'm one of the developers on the core open source product. Ansible is an automation tool, and I think that's one of the most simple descriptions you can give it. It strives to be simple, strives to be readable, auditable. It is a tool that plays well with others, and I'm going to show you how. If I can get the slide to work. Here we are. So, and now it works too fast. So Ansible uses YAML as a data description language. This keeps the books, the actions very structured, very easy to read, and very parsable and easy to generate. It also deals very well with JSON, which is actually a subset of YAML. Not on purpose, they were developed in separate, but JSON is actual YAML shorthand. This makes it very easy to read for humans and machines alike, which is, I think, one of the big issues that we have with most of the tools. I'm not touching it anymore. It also does not require knowledge of a programming language. It always helps to know programming, but Ansible does not have that as a requirement. The only thing that you're required to know is how you would normally fix a problem, and then translate that into Ansible instructions. One thing that traditionally has been a problem with configuration management systems is that you give a state or you give a set of instructions, but you never know how they're going to execute. Ansible is very simple. Instruction A comes first, then it gets executed first. If instruction B gets defined second, it gets executed second. So dependencies are very easy. You want something to happen before something else, you put it first. It's very procedural here. It's not complicated. Some people, especially programmers or people that prefer to make infrastructure as code, find this sometimes puzzling because it's so simple that it goes against what they're used to. And normally they try to create this very complicated solution. And one thing I always tell them is that if you're looking at creating closures, looking at lambdas, anything, you've complicated the problem too much. Step back, think of what you want to do, not how you want to do it. And there's normally a much easier way to do it in Ansible. Being such a simple tool, it's also a very flexible tool. It started out to manage servers. The author of Ansible was in the middle of a job, and he was dealing with managing 1,000 new servers that he had to get up in 2 weeks. And he just decided, look, none of the other tools work for me. It's going to be too complicated. Let me just do something fast and simple. Use existing tools. How do you administer machines normally? Since Telnet was deemed inappropriate, SSH has been the #1 tool that every Unix admin has used to access their servers. You already have those credentials. You normally have sudo or su set up, or you have root keys. So he said, let me leverage what already exists there. So Ansible started leveraging your existing systems. You don't need to install anything. This is one other powerful thing. It's agentless. You can set up an agent with Ansible pull, but the primary use of Ansible is you have a push model. You don't need to install anything on your targets, just Python with JSON, which in Red Hat has been installed, I think, since 5.5 or 5.6. I think 5.5 you need to install simple JSON. After that, JSON's installed with Python. We support Python 2.4 on the target machines. You need Python 2.6 on the parent. I'm a slide behind. I'm lost right now. Or ahead. Or without slides. I'm just going to wing this from now on. Another thing is that he needed to support a heterogeneous network, multiple different Unices. So he standardized on POSIX to make it easy to translate from one system to another. From the start, we've been supporting BSD, AIX, Solaris, not because we love them, but because we had to, and it was easy to transpose. There's some minor differences, and we normally get contributions from people that work every day with AIX, Solaris, to be able to make Ansible work across all these OSs. The ability to extend on top of the existing frameworks means you can get started right away. You just need to install Ansible on your laptop, and in 5 minutes you're configuring machines, 1 or 50. Ansible, I always like to reduce it. It's just this thing that lets you execute a task on a server and then multiply by n, both the task and the servers. It's a simplification of what it does in the end. There's a lot of complicated things, but once you think about it, is what you normally want to do in automation, be it you deploying an application, installing a security patch, creating your development users, setting up a database. You want to run a task on a server. To do any of the things I've said, you need 5, 10, 20 tasks. To do it in a production system with redundancy, now you need to do it on 10, 15, 20 servers. Ansible lets you take from the very simple reduced list and look at it as a simple reduced list and then just multiply the power across servers. It's very efficient since you don't need to install anything, and it uses SSH already. Having no agents, nothing running, it's not going to impact your applications except when you need it to. It'll run when you tell it to run. It won't run, won't check. Not having an agent has some advantages. You're not competing in CPU cycles with your application. Security. Ansible does not roll out its own security, doesn't have a daemon running, doesn't have its own protocols opening into the network. It's using the security you already know and you already trust. SSH is there. I can't think of a more secure protocol that more people depend on every day than SSH. And for privilege escalation, you can do what, as I said before, what you were already doing. Using SSH keys to log in as root, or use sudo and su to leverage specific privileges that you need to deal with your application, your configuration, or whatever else. And this simplicity ends up being incredibly powerful. It's structured in a way just like its Unix roots to be able to leverage a bunch of plugins to let it do whatever task it needs. When I started working with Ansible, there were around 30, 40 plugins. We're around 300 right now. These are task plugins that let you do things. We have other plugins. For example, we support Windows through a WinRM connection plugin. So we use WinRM to shove PowerShell into Windows and run that. The normal task plugins, the ones that copy a file, restart servers, these are simple, very small scripts. The ones that Ansible ships with are Python, but it can be done in any scripting language. There's people doing them in Ruby and Bash. These modules, these simple scripts, just need to read and return JSON. And then Ansible will take care of copying the script where it needs to be, running it, taking the results, and giving them back to you. And this little tool is very good for all these purposes. But once you get into the enterprise, you need a bit more. You need reporting, you need a console, you need a role-based access control. And you need to be able to delegate a lot of these complex tasks to people that just know how to push the button you tell them. Ansible itself is pretty good for sysadmins, DevOps, even developers, QA people, to automate their processes. But there gets a point that the guy automating the process should not be the guy always running it. And it's very easy to give Ansible to other people and let them run it. But there's the issue about the credentials that they need to create these actions. This is where the proprietary product Tower for the enterprise comes in, which allows people to put in a centralized, auditable manner and delegate control to whoever needs to execute the task and give them the ability to execute as root without giving them the credentials to do anything they want as root. And this is what our friends here have been using to bring the data center together with the cloud, because Ansible doesn't care where the machine is. It has a bunch of plugins for each cloud, several hundred plugins just dedicated to managing cloud infrastructure. But the other plugins that manage the machine, it's transparent. I don't care that the machine is on AWS, on Azure, I never pronounce that right. Or they're the Dell 500s that you haven't been able to get rid of in 15 years in your data center that are just rotting away, but they're critical infrastructure you can't touch because nobody knows how they work or wants to know how they work. And now you need to marry that with all the new infrastructure you're creating. Ansible doesn't care. They're all machines to it. It's all transparent. And it's a good tool to unify. And I'm passing it back to Isaac. And now it works.
All right. Sorry for the technical difficulties here. So I think it's Office here, LibreOffice here. So I talked a little bit about Ansible Tower for that. So let me just back out of this, and I'm going to show it here, as long as my display holds up. So with Ansible Tower, you sort of have that single dashboard to work with here. So I've only got a couple of servers because, as you can see, his laptop's already having problems, so four more. But set up basically some instances here. So we'll have a database server and then some servers to support the OpenShift environment. So from here, from this console, I can start to look at it. I can begin to drill down, get some of the aspects of this one. So this would be equivalent to defining up your host, if you're familiar with that. Set up your inventory for your database servers, and so we've just got some common ones here. The other advantage that we have is now we can manage the other one we have is, so we can manage organizations, so we can start to group all of our servers in that place. And certainly add in for our users, manage from this standpoint. So all this typical stuff you'd want from the thing. I haven't set up a team for this one. But you talked a little bit about managing credentials. So we can basically start to manage these and store them in this environment. So either we can just always have it to prompt to always ask to log in for root, or we can always ask for the SSH password, or we can also always configure our SSH keys in this environment. So this sort of gives us the ability to manage these keys in a central place without having to share around key files all over the place from that environment. We can then define our set up sort of our projects. So we just have the obligatory Hello World example that we have, and we'll take a little bit of an example of what these are. But these are basically become Ansible playbooks inside of this environment. And then this is really where we start to grab into what our servers are. So I can start to manage all these, bundle all these groups in here. So we'll see this in action a little bit later, but then we can also look at OpenShift nodes and start to Z from here. So then both these two, I have two nodes that can manage this. We can begin to define jobs. Seems like I have like 3 minutes.
About Ansible is that it strives to be idempotent. So if you failed in the middle of a job because your screen goes out, you can just run it again and check up to the point that you were okay, and then it'll again it strives to be. It's not always 100%, but as long as you write your playbooks in that way, you can run them over and over just to verify that the status is okay.
So I can set up an inventory. I can basically say, here's the list of servers I want to have, here's the list of projects I want to have, and then I can run and say, go ahead and run the jobs. I seem to be fluctuating between resolution here. This will be quick. So I can define a job. I can say what the job is, and then define that. So if you're familiar with the Ansible playbook status here, so this would basically be my job for the Hello World. It's very simple, as talked about earlier, just a very basic Ansible playbook here. So if I run this job, what do you think is going to happen? And all the servers is going to sit there and execute and say hello world and run that shell command from there. And so I can now define this thing within Ansible Tower, go through the job definitions. So within Ansible Tower, so you take a look at it on the screen, so I can define my template, I can define my playbook, I can go ahead and then run that playbook on those servers that are managed there. So the only thing we need is SSH. The only thing that we need to basically then we need the credentials in there, so I can hook into a legacy existing MySQL environment that's already in my environment, plug in Ansible. Since it's agentless, all it has to do is just have connection credentials. And then now, let's say I've got this MySQL server that's been running for months. I can go ahead and basically do an update on that and get it right up to the right patch levels and be able to do that, basically connecting up to that server. Take the inventory of what's basically in there. If I need to now be able to put that server into management and maybe I want to start managing creation of databases, I can go ahead and come up with my Ansible playbook, go ahead and do create database, and then basically go out and create that database off using the Ansible thing. Define that job template that we saw between a few flickers, and then basically go ahead and push out the database and push it into those environments, and then I can manage that from that standpoint. By that same token, one of the things we're looking at with the new OpenShift v3, and which we're hoping to be able to show a little bit, is now I can basically go ahead and create I can now shell into those boxes to anything that has command line tools, right? I can now write a script around there. I can shell out, I can run these, execute these OpenShift commands. I can say, go ahead and create me a project.
Keeps going away.
Go ahead and create me a project in OpenShift. Span that up. No. And then basically go ahead and create a project and add the users to these projects and then spin them up in these environments. So the tools that are available now with OpenShift, or if we wanted to use the REST API modules that you can use with Ansible as well to make those calls, we can go ahead and do that as well. The benefit of doing this is it takes little time to do that as long as you know the commands. So if you know if you can script something in Bash, if that's your way, you can basically then start to tear that apart, create the idempotent scripts that you want for Ansible, start to get the state that you want to have desired into, and manage it that way. You can also sit there with Ansible Tower, be able to create little surveys in the view. So if you want to create a script to go ahead and create a new user, it can pop up a survey, say go create this user. It'll spin it up, give it the username and password, even get to the point where you can say, create me a user, add it to this path, and move forward, and create the application in there. That gives you the ability to sort of integrate into the new environments with the OpenShift, as well as your legacy stuff if you have MySQL and all your existing data center, sort of easily drop in your environment in there and get up and running to try and grab some sanity and the control from there, and as well as to start to get some standardization across. So that the MySQL that you build up there and that you've been building in your data center is the exact same thing as the MySQL that you're building up in Amazon, the same thing that you've been building out in OpenStack environments or what have you. The point is to try and build out consistency coming up with your templates and from that standpoint. And I think without being able to show anything on the screen, I can't really show some of the features that we were talking about doing there with the OpenShift aspects. What I would say is that one of the things there you'll hear a lot about this week with OpenShift v3, with the adoption of standardized containers approaches that bring in Kubernetes libraries from there. You're going to be able to have the additional ability now to pull out Docker images or anything else that's out there and pull that into your environment now that's running in the OpenShift. So that's basically going to give you a much broader catalog to start to pull in. You as the apps admin, that is also going to create much more chaos unless you can come in and start to get a centralized tool to manage that, to sort of get a figure about what's out there in your environment and how you're going to deploy that. You still have, if you've been familiar with OpenShift and you've done the V2 days, you're still going to have the ability to spin up the environment, pull out your code from your Git repos, deploy into the images, and from that standpoint. But so this week, what I would say is, as you're out here, is check out OpenShift v3, and if you're interested in Ansible Tower and some of the demos and stuff out there, what I will say is, I'm here on the booth floor, he's here on the booth floor. Come by, stop by us, we'll show a little more personal thing, and won't have as many screen flickers. So with that,
A couple of other things, for example, they use Ansible to centralize and have one tool to manage everything, but it's not necessarily, Ansible plays well with others. There's people that use it to install Chef or Puppet because they already have a legacy of systems already and information in there that they're not going to just throw away. Ansible is a very nice glue tool that can come in and leverage what you already have and build the new stuff, or marry the new stuff and the old stuff. So it's not necessarily a tool that will substitute all the others, though it can. But it's a tool that you can bring in to just make it the glue of the others and manage everything in for me, a saner manner. I've been a sysadmin slash programmer slash network admin for over 25 years, and I've automated in everything from Corn shell, POSIX shell, Bash, Perl, not Ruby. That's the one thing I haven't. I have used Puppet, I have used Chef, and I ended up using Ansible when I was creating my own tool because I was very dissatisfied with the existing ones. When I was halfway through mine, I saw Ansible. I said, oh, this works well, but I'm not going to throw away my existing stuff, nor the Puppet installation I had. And Ansible just came in and started managing everything without interfering with the other tools. That's one of the beauties of it. And especially when you have legacy systems and you're trying to go to the cloud, it's really hard to manage it with one tool. Ansible is actually one tool that makes that easy. Even if you have other tools managing or in the middle, it can actually work well with others.